Okay, trig values for double angles. Okay, so there's a couple double angle formulas, and we'll kind of bring them up here quickly. This is them. We've highlighted them on the other side, specifically the green, the blue, and the purple one are the ones we're talking about. Okay, this is just an old one that does come in handy. So let's go back to our other page. If cos theta is equal to -2/3, and we are within this range here for theta 0 to pi/2, find cos 2 theta and sine 2 theta, or double angles. I'm going to draw a quadrant here, okay, just so we have an idea of what we're talking about. This is 0. This is either 90 degrees or pi/2, right? This is 180 or pi. This becomes 3/2 pi or 270. And this becomes 2 pi or 360 degrees. So because they say that we're in the range, what they're saying is as long as angles are anywhere from 0 to 360, okay, that's where we're ranging from 0 to 360. Because if they didn't give us that range, there are multiple angles that could be 2 pi, right? We could have 360, we can have 720. I think the next one's like 1080. Like it continues to go up, right? So we're going within that range. Cos is a -2/3. Okay, well, let's talk about our basic trig ratios. Cos theta is equal to the adjacent over the hypotenuse, right? In other words, what this means for us, and cos is negative. So let's think of our CAST system, right? C-A-S-T, okay? C-A-S-T, well, everything's positive here, so we know we're not in quadrant 1. Quadrant 2, we could be in. Quadrant 3, we technically could be in. Quadrant 4, we can't because cos is positive in there. So we're either in quadrant 2 or quadrant 3 in this question. And they've given us a -2. So adjacent being, our adjacent angle here being -2. So we go back 2 and up 3. Okay, 1, 2, 3. So it's going like that, right? So this height, oh, sorry, that's wrong. The hypotenuse is 3. Hypotenuse being 3, we go back 2. So we either have, we've gone to -2. Is this making sense so far? Hold on. That being -2, in other words, this distance here is -2, okay? Because that is our adjacent. And then our hypotenuse is technically a distance of 3, okay?
You have to find the other side, right?
Yeah, that's exactly it. We would want to, if we're looking for sine theta. But for cos 2 theta, we may be able to work with just this. Okay, we might be able to work with just this. And we got to figure out which of what we're going to be working with here. The radius is 3. The x value is -2. We don't know what our y value is, right? Our y value is missing. Our x value is -2. Let's get our formula from the other page here. So cos double formula is equal to, and they have many of them. Okay, so we're going to just talk about a basic one here. In fact, we'll take up, I guess we could write all 3. I'll write the original one first. Cos double theta is cos squared theta minus sine squared theta, right, from the other page there. So double angle cos, so cos 2 theta is equal to cos squared theta minus sine squared theta, right? All right, now in order to solve this one here, we need a value of cos squared theta and sine squared theta, okay? But we don't have a sine squared because we don't know what this other side is. So what we're going to try to do is there's ways to manipulate this formula. We're going to try to manipulate this so we're only working with cos because we do have a measurement for cos. So instead of actually going through the process of finding sine, even though we're going to have to in the second question of this, let's rearrange this formula. We know we have another formula that states cos squared theta plus sine squared theta is equal to what?
1.
1, that's right. Well, let's try to replace our sine squared theta. So we'll set this equal to sine squared theta is equal to 1 minus cos squared theta. We know that. Perfect. So this will now replace our sine squared theta. We get cos double theta is equal to cos squared theta minus 1 minus cos squared theta. Okay, that's what we just plugged in there. We got to distribute that negative term into both of these. So we get cos 2 theta is equal to cos squared theta minus 1 plus cos squared theta, and when we add the two cos squared thetas together, 2 cos squared theta minus 1. Okay, now we only have a cos in this formula, right? Which makes this easier for us because we know that it said cos theta was equal to negative 2 over 3. Is that correct?
Yeah.
Yeah, it was equal to negative 2 over 3. Okay, so in other words, if cos theta is equal to negative 2 over 3, what we're going to do is we're going to plug this value in for it, and then because it's squared technically, right, we're going to square this value. We're looking to square this. So that then means we have 2 times, and we're plugging in our negative 2 over 3, because that's essentially what cos theta was equal to. But we need to square it, like we said. Okay. And then we're going to be subtracting 1. Okay. From there, we work this out. We get 2 times, this will be a positive term, right? So it's going to be 4 over 9. 2 times 4 over 9 minus 1. It's going to give us 8 over 9 minus 1. 1 is essentially 9 over 9, right? So in other words, it's become negative 1/9. Are you okay with what I did there with fractions?
Wait, isn't it negative 1 over 1?
Yeah. Okay, so this would technically be 1 over 1, but we need common denominators, right? So in other words, this could be written as 8 over 9 minus 9 over 9. And when we subtract them, yeah, we get negative 1. So that's what we did there. Okay, so that's for the first one, and we'll do a second video for sine double angle theta. Okay, does that make sense for the first one? Okay. To recap that, because cos is technically negative in both quadrants, whether we're in this quadrant here, like this would have been the 3, okay, because it's negative in both quadrants, our answer is going to be negative 1/9, whether we're talking about, you know, our second quadrant or our third quadrant, right? And the next video we're going to do is going to be on sine double angle theta. That's going to change a little because sine is technically positive in quadrant 2 and negative in quadrant 3, which is going to change our answer, right? But we used quadrant 2 and 3 because that's when cos was negative. We knew it'd be in there, okay?